In this lesson, you'll be using this packet to take your notes, and the whole lesson is on divisibility tests for 3 and 9. So we're going to look at which numbers we could divide by 3 and which numbers we could divide by 9. Before you start writing in this packet, we need to record some definitions for the words factor and multiple. A factor is what we multiply to get the product, and a multiple is what we get by multiplying a given number by another. So for example, the factors of the number 4 would be 1 and 4, or 1 times 4, and 2 times 2. So the factors of the number 4 are 1, 4, 2, and 2. The multiples of the number 4, though, are what we get by multiplying 4 by another number. So 4 times 0 is 0. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. So these are the multiples of the number 4. We have to know the difference between these for this lesson to really make sense. So make sure you record those. And then let's move on to this opening exercise. So we have a list of 10 numbers that have been given to us. And what we're going to do is we're going to take these numbers and we're going to sort them into these circles to determine if this number down here is a factor of what they give us up here. Some of these numbers can be placed in more than one circle. Let's do 24 together. For the number 24, we're deciding, is 2 a factor of 24? In other words, is 24 divisible by 2? Yes. When we divide that, 24 divided by 2, we don't get a remainder. So we're thinking, does this go into 24 evenly? Yes. Is 4 a factor of 24? Yes. So I'm also going to write 24 in the 4 bubble. Is 5 a factor of 24? No. So we're not going to write it here. How about 8? Yep. 8 times 3 is 24. So 8 is a factor of 24. And is 10 a factor of 24? No. So now I'm done with 24 and we're going to move on to 36. What I want you to do is pause the video and set a timer on your iPad for 5 minutes. And you can work with your shoulder partners or someone at your table to look at these numbers that they give you up at the top and see if you and a partner can work together to determine the factors. When the 5 minutes is up, I want you to unpause this video, keep watching, and you'll get the answers. All right, so here are the answers. This is what your bubbles should look like. If there are any that you missed, I want you to highlight them so that you can remember, and you might even make a note of why. Maybe there was a factor you forgot, maybe you needed to use your multiplication chart. But hopefully that exercise helped you to start thinking about rules of divisibility. This whole lesson is about why certain numbers can be divided by factors and you do not get a remainder. So on the next page, we're going to set up our notes. I actually want you to pause again, write all of these sentence frames, and then we'll talk about what they mean. So go ahead and pause. All right, so you should be unpaused now, and we're just going to record all of the divisibility rules for these numbers. So let's start with the divisibility rule for 2. Numbers are divisible by 2. Divisible means like dividable. Numbers are divisible by 2 if and only if its unit digit is 0, 2, 4, 6, or 8. And when they say unit digit, they mean the number in the ones place. Okay? Let's look at the divisibility rule for 4. A number is divisible by 4 if and only if its last 2 digits are a number divisible by 4. The divisibility rule for 5 is if and only if its last unit digit is 0 or 5. The divisibility rule for 8 is if and only if its last 3 digits are a number divisible by 8. The divisibility rule for 10 is if and only if its unit digit is 0. They do make a special note here that decimal numbers do not follow the divisibility tests. So they're right here, this fraction parts, they're saying if you have a decimal that has a number in the 10th place, the 100th place, or the thousandth place, any decimal number, that these divisibility rules don't count. Okay, so this is if we have whole numbers only. All of those rules that we just talked about should be pretty familiar. If you've studied our multiplication chart, if you know your math facts, if you've done some division before, you should kind of already know those. But the rules that might be new for a 5th or 6th grade student will be the divisibility rules for 3 and 9. So go ahead and record these, pause the video, and then we'll talk about it. Now that you're done writing those, let's read them together. Numbers are divisible by 3 if the sum of the digits is divisible by 3. Numbers are divisible by 9 if the sum of the digits is divisible by 9. That means if you add up, because sum means add, if you add up all the digits in a number and you can divide it by 3, then the whole number you can divide by 3. And same here. If you add up all the digits in a number and you can divide that number by 9, then it's divisible by 9. So for example, if I have the number 222 and I want to know, is 222 divisible by 3? They're telling me I can do 2 plus 2 plus 2 is 6. Can I do 6 divided by 3 and not get a remainder? Absolutely. So they're telling me, since I can get an answer here without a remainder, this whole number is divisible by 3. If I use that one down here for 9, 2 plus 2 plus 2 is 6. Can I do 6 divided by 9? No. I'll get a fraction. I'll have a remainder. So I know that 222 is divisible by 3, but not divisible by 9. Let's look at a number that's a little bit more challenging. In example 1, using the divisibility rules that we just discussed. So they give us 378. That number is not as nice as 222. And they ask us to expand the number. When we expand it, we're just putting it in expanded form. 300 plus 70 plus 8. Do you remember the second step? We pull out the first digit. Now I have 3 times 100 plus 7 times 10 plus 8 times 1. If we turn on to the next page, we'll take the expanded form that we just made, and I'll write it again for you here so that you don't have to flip. And actually these should be plus signs, sorry, I forgot my parentheses. So we have 3 times 100 plus 7 times 10 plus 8. Now that we've put it in expanded form, they're asking us to decompose the expression. That means break it apart, take it apart, so that we have factors by 9. So 100 is not really factorable by 9. We can do 3 times 99 plus 1. 99 divided by 9 works. So they want us to decompose this so that we have numbers that are easier to work with when it comes to the number 9. I can do 7 times 9 plus 1. And I'm just going to leave our friend 8 at the end there. Okay. Now, we can write our final decomposition like this. And we're going to factor our 9. And if we think, what is the sum of the 3 digits? We get 18. The sum of the 3 digits is 18. And is 18 divisible by 9? Can we do 18 divided by 9? Yes, we can. Therefore, we can now answer this question. Is the number 378 divisible by 9? Why or why not? Yes, because the sum of the digits is divisible by 9. Letter G here asks us to do the same question again, so you can cross that out. Now, you guys, if this whole process, breaking it into expanded form, decomposing it, pulling out the factors, if this looks really complicated to you and right now you're going, where are all these extra numbers coming from? Then what you can actually do is save this as an example, and we can go back to thinking we need the sum of the digits. I can just add the digits together. 3 plus 7 plus 8. 10 plus 8 is 18. Can I divide 18 by 9? This work up here, if you look at this and you go, that makes perfect sense. I'm going to decompose it. I'm going to factor the numbers out. Great. If that makes sense to you, use it. But if you would like the simple method of just adding the digits together and this makes sense to you, use that. I want you to use whatever feels the most comfortable strategy for you. All right, so you guys are going to work on example 2. Is this number divisible by 3 or 9 or both? Why or why not? And then you can turn on to the next page, work on this next page with your team. I'll come around if you have any questions, but when you get to the end, this lesson summary, this page, this problem set is your exit ticket, and I want you to do this independently. Thanks so much.